Here we have the ABIT operating system. I'll reset it and it's going to attempt to start 10 million applications. It just goes through zeroing all the memory. It's just running on QEMU with 6 gig. It won't have a chance to create 10 million applications, but it will try. Here we go, it's counting down. So on this screen what we have here is the number of applications it created, and this counter here, I'll show you what this counter does in a second. This counter here is a system call, and I'll just increase the counter to make sure the applications were created. I can track the handlers, or threads as we sometimes call them. I call them handlers, or I can track applications. It's just a nice way for me to track things. So we tried to create 10 million applications. We created 260,136 applications in 0.18 of a second, which is roughly 1.4 million applications. So I'll just show you the source code. I'll just move this out of the way. Over here, and here's the source code. So this is the mark me that I was talking about, the thing here with the counter. All I do here in the operating system is I just increase this counter, and this counter is brought about, I'll show you, in here. Just some counter. This line here just prints out to the console. It's been told to go back a certain amount of characters, so it always starts at the top, otherwise we have to scroll down. And it just prints out this. And I've got my own little formatting commands here. There's one application when it first loads, which is the first application, and it comes in and executes this. We disable context switching. The inject key just saves me from having to quickly press keys, for instances like this. So it just pushes the L key for me. That's what inject key does. We've got the simple countdown, which you saw on the screen, it counting down. This is the application I want to start from the base. The base code, which is 1, and 1 is this the root application inside the ABIT operating system. This is how many we're going to try to create. We just print out something to the screen again, which you saw. We have our timer, which we just check the number of ticks in the system, and we come through here and we tell it to start this many in one go. So this is a cloud operating system, so it's for expanding or for growing extremely fast. So that's what it's designed for. So you can tell it to grow as many as you like, just in one system call. And as you can see, it just adds to the amount started. If it didn't start any, it drops out, or it's reached the amount, it falls out. We calculate the time taken. We calculate the apps per second based on the time taken and the number of apps that were started. And we output that to the screen there. So I'll run it again so you can have a look. And again, it's just zeroing all the memory. It's much more efficient to zero the memory at the start. And zips through, starts counting down. Gone. Here we go. 1.2 million that time. We are running under QEMU, and I've also got my screen logger going. But it sometimes sits around, well, most of the time it sits around 1.6 million apps per second. So what we'll do is we'll come in here, and I've also got some Linux code. So to test Linux, so here we can have the Linux code. And I'm just using the simple fork up here, the fork command, if you can follow my cursor. And I'm asking for the same thing. I understand this is slightly different, it's in a for loop, and I'll do that with mine shortly. So here we do, we start it up, and off it goes. Linux created roughly 40,000, it took it 3.5 seconds, which is roughly 11,000 per second. So I'll go back to my operating system here, And what we'll do is we'll just put it in the same sort of for loop. We'll tell it to create 1 every time instead of a group of 10 million. Come in here and I'll just recompile it, which is over here. So it's just recompiling the operating system and the user space. I've got it all in one makefile. There we go, it's up, and here it is here running. And this time we'll go through and create them singularly, very similar to the fork function. 4, 3. And that took a little bit longer. As I was saying, it's a cloud operating system, so it's built to scale up and down extremely fast. It's not really designed for the simple for loop down here, but it's very fast. It's very fast. I've got another video which I'm creating, and that'll be on a server with 256 gigabytes. And that will enable you to see this counter here spinning up. So you'll see the number of apps will be full at 10 million. They'll be able to get 10 million on there. And then you'll see the counter just slowly grow as the applications get started. This machine's just too fast, and there's just not enough memory. I'll get that other video up shortly and you'll be able to look at that. Awesome, thank you.